Hello, we'll look at system of linear equations in two variables. We have seen uh, the graph of equation of the form ax plus by equals c to be straight lines, and which is also linear. Okay? Meaning it's just a straight line. Because the graph is a straight line, the equation is said to be a linear equation. Okay? So because this, if you look at the graph of ax plus by equals c is called a linear equation. Two linear equations together form a linear system of equations. So when we have two linear equations together, they form a linear system of equations. For example, we have the equation 3x minus 2y equals 6. And if we have the equation 2x plus 4y equals 20. This is a linear system because we have two equations. Yeah. The solution set to the system is the set of all order pair that satisfy both equations. So whenever you have a solution, that solution must satisfy the first equation and the second equation. Now, if we graph each equation on the same set of axes, we can surely see the solution. So let me show you the graph of these two equations. So if I use my computer program, on which you can do it by hand, and you graph these two equations, okay, you will see that these two equations intersect at a point, and that point is 4, 3. This means, okay, the solution is 4, 3, or we can say x equals 4 and y equals 3. Now, if we do that and we check our answer, as I said before, it must satisfy both of them. So we have 3x minus 2y equals 6. And we also have 2x plus 4y equals 20. So if we replace the x and the y, replace x and y, x with 4 and y with 3, this should be a solution to this equation. So if we do this, 3 times 4 is 12, minus 2 times 3 is minus 6. Let's see if that's equal to 6. 12 minus 6 is 6, so 6 is equal to 6, that checks. So x equal 4 and y equal 3 is a solution to the equation 2x, 3x minus 2y equals 6. Now, for it to be a solution to the system, it must also check in the second equation. In both equations, this must be checked. So if I check it now on the second equation, we have 2. Remember, x is 4 and y is 3. If we distribute, 2 times 4 is 8. Positive 4 times 3 is 12. And 8 plus 12 is 20 is equal to 20. And that also check. So we can also see that x equals 4 and y equals 3 is a solution to the equation 2x plus 4y equals 20. And since they're a solution to both equations, then x equals 4 and y equals 3 is the solution to the system. It must satisfy both equations. Yeah? If it does not satisfy both equations, then it is not a solution. Now, you will see, okay, that not all system will have a solution. And graphically, okay, graphically, you will see this. There are 3 cases, okay, there are 3 cases to illustrate this. So let me show you the 3 cases on a graph. So here are the 3 scenarios, okay? Here are the 3 scenarios that whenever you graph something, or 2 lines that you will see. The first case is what we've just looked at, okay? Case number 1, here would be your solution. The point of intersection is the solution. In case number 2, there is no point of intersection, so there's no solution. In case number 3, what happens here is that really, and you don't see it because both my graphs were in red, you have 2 lines, one line being blue, one line being red, and the red line and the blue line falls on top of each other. And when this happens, we say that there are infinite solutions. Yeah, there are infinite solutions. So these are the only 3 cases that you will see when you solve system by graphing. Okay. So we've seen how to graph already, okay? Or you should be familiar how to graph an equation. But although you are familiar with how to graph, we will do one or two examples to see which one of these cases. So let's jump straight into that. Okay. So, example, solve the system by graphing. Okay. And the first equation we have is 3x minus 2y is equal to 6. And the second equation is x minus y is equal to 1. What I'm going to do, just so that we're on the same page, and I don't have to keep writing these equations over and over again, I am going to call the first equation, equation 1. So I'm going to call this EQ1. And I'm going to call the second one EQ2. So let's graph equation 1. Let us graph equation 1, which is 3x minus 2y equals 6. Now remember, you have learned at least 3 ways to graph equations. Okay? So in this example, I'm going to graph by finding the intercepts. And remember, to find x-intercept, let y equal 0. And to find a y-intercept, let x equal 0. Yeah? So let's go ahead and find the x-intercept first. So the equation we have is 3x minus 2, but I am going to replace y with 0. And that is equal to 6. Now 2 minus 2 times 0, that will be 0. So we're left with 3x is equal to 6. And to get x by itself, what we will do is divide both sides by 3. And that leaves me with the 3 divided by 3 is 1. So 1x is equal to 2. Okay. Now, as I said before, remember the point here. Your point is really 2 comma 0. Because remember, you said y is equal to 0. Okay. So that's your point. Your point is 2 comma 0. Now, let's find now our y-intercept. And to find our y-intercept, we know x has to be 0. So now we have 3, and instead of x, we're going to write 0. Okay? And we know that anything times 0 goes to 0. So we're left with minus 2y is equal to 6. And to get y by itself, what we will do is divide both sides now by negative 2. Negative 2. And the 2's will cancel and the negative will cancel, leaving me with a positive y is equal to, and 6 divided by negative 2 is negative 3. So my point here, my point is, okay, remember you choose x to be 0. So here is 0 comma minus 3, right? So we have to plot these points, and we will be able to graph this equation. Okay. But I'm going to leave the graphing for a few minutes. Let's look, actually, let's graph it because I don't want you to get lost. Let's graph it. So if I make my XY axis and I plot the point if I plot the point 2, 0, which will be here, and it does fall on the x-axis because that was my x-intercept, okay? And now if I plot the point 0, -3, that does fall on the y-axis because it is my y-intercept. And if I connect those two points, we will have an equation or a line, okay, that looks like that. And that is the equation 3x minus 2y equals 6. 3x minus 2y equals 6. So we have only graphed one equation. Now, let's look at my second equation. Remember, it's a system. So equation 2 here is x minus y equals 1. So x minus y. So we will now graph x minus y equals 1, okay, on the same graph above. So what this means is that once we get this graph, we're going to go back and we're going to graph it on this xy axis here, okay? So we have many ways, okay? So we want to graph x minus y equals 1. And as we said, we can graph this using the intercepts. So let's look at the x-intercept and let's find the y-intercept. Okay? Remember, to find x-intercept, we let y equal 0. And to find y-intercept, we let x equal 0. Yeah? So in our equation, we have x minus, instead of y, I'm going to write 0. And that is equal to 1. Now x minus 0 is the same as 0, so x is equal to 1. And don't forget, your point here is 1, comma, remember y is 0 because you had said y is 0. Okay? Now, if we find a y-intercept, okay, we have the equation is x minus y equals 1. So instead of x, I'm now going to write 0. So 0 minus y equals 1. And this here we know will be 0. So we end up with minus y. Don't forget that minus is equal to 1. And then what I will do to get rid of the minus, I'll divide both sides by -1. So the negative 1 divided by negative 1 becomes positive, and positive divided by negative is negative. Now it's very important, don't forget your point. Your point here, remember you had chose x to be 0. So 0 and the y value you found to be minus 1. So now let's go back to our graph and let's plot the x-intercept 1, 0. And if I go up here and I plot my x-intercept to be 1, 0, I will get this point. Okay? And if I plot my y-intercept, my y-intercept now is 0. My y-intercept is 0, negative 1. So if I go here and I plot my y-intercept as 0, negative 1, I get that point. Okay? Now, if I connect those two dots, you will see that the line does cross. And the green line, don't forget, is x minus y equals 1. Okay? Let me write it somewhere else. It's clearly visible. X minus y equals 1. Now, you will see that these two lines does intersect. Okay? But they intersect at some point that is not that clear to read from the graph. Okay? So this here, whatever this point is here, this is our solution. The solution is some x comma y. Okay? So, as I was saying, this point here is your solution. Now you'll notice that that solution is not very easy to read. And there could be a couple of reasons why. One of them is maybe because when we drew our graph was not clearly done. And clearly you will see here that line didn't quite pass through that point. Okay? So this is one of the reasons why graphing is not really an appropriate method. It will work, but you have to be extremely neat. So if I redraw my graph, let's erase my green line. Oops. Okay. Let's erase my green line. So I'm going to write back the equation of the red line, which is 3x minus 2y equals 6. And if I try to redraw my green line, still a little bit off. I'm sure there's a way to do this where it's easier with my program that I'm using. So it appears that here is my solution. Okay, and that solution point really is 4, 3. Now, I knew what the solution was, so it was important for me to make sure that it crossed at that point. You will probably don't know what your solution is. So x is 4 and y is 3. And let's check that, right? It's very important that we check. So my green equation here is x minus y equals 1. Okay? So 4 comma 3. Let's do a check. Let's check. Check the solution 4 comma 3. So remember, this is x and this is y. Our first equation, equation 1, which we call equation 1, was 3x minus 2y equals 6, right? Remember, I labeled my equation then. Right? This is my first equation, and this was my second equation. 3x minus 2y equals 6. Okay? And in that equation, we want to replace x with 4, and we want to replace y with 3. And we want to see if this is equal. So 3 times 4 is 12, 2 times 3 is 6, and 12 minus 6 is equal to 6, so that checks. Now remember I said it has to check both equations. So let's check equation 2. And equation 2, if you recall, is x minus y is equal to 1. So instead of x, I'm going to write 4, and instead of y, I'm going to write 3. And we want to see if the left side is equal to the right side. And 4 minus 3 is 1. 1 is equal to 1, and that checks. Therefore, this has been verified, okay, that 4 comma 3 is a solution. Remember, you can say, or we can say that x equals 4, y equals 3, okay, is the solution. Now, if you had checked any other point, you will see it is not a solution. So this was a good example to show you that graphing, if you're not very neat, you are not going to get the correct answer, okay? You have to be very precise with your graph to make sure you have the correct answer. Look at another example, okay? Solve, so example, solve the system by graphing. And we have 5x minus 2y is equal to 5. And we have minus 10x plus 4y is equal to 15. So once again here, what I'm going to do, I'm going to call this equation 1, and I'm going to call this equation 2, okay? Just for writing purposes. So when I refer to them, you will know what I'm referring to. So let's find the points first in the graph for equation 1. So equation 1, we have 5x minus 2y is equal to 5. And equation 2, we know it's minus 10x plus 4y equals 15. So let's find the x and y intercept for both of them, okay? So x-intercept and y-intercept. Remember, for x-intercept, let y equal 0. For y-intercept, let x equal 0. And if we plug in these values, we have 5x minus 2, y is 0, and that's equal to 5. This here will be 0, so we have 5x is equal to 5, and now we divide both sides by 5, so this becomes 1x, and 5 divided by 5 is 1. Now don't forget that the point here, your point is 1 comma 0, because we said y is equal to 0. Okay? Now, let's find our y-intercept. Our y-intercept, x has to be 0. So 5 instead of x now, I write 0. Okay? Minus 2y is equal to 5. And 5 minus 0, or 5 times 0 is 0. So I'm left with minus 2y is equal to 5. And we will divide both sides by now negative 2. Divide both sides by negative 2. And when I do that, the negative 2's become a 1, positive 1, so y is equal to 5 over negative 2. Now don't forget, your point here, okay, your point is 0, okay, 0 comma 5 over minus 2. Okay. Now remember, for graphing purposes, 5 over minus 2 is the same as minus 2 and 1/2. Okay. Now, so those are my 2 points for that equation. Now let's look at the second equation and get my intercepts also. So for x-intercept and then y-intercept. Yeah? And if I do this, remember for x-intercept, let y equal 0. Okay. I should get rid of that. And for y-intercept, let x equal 0. And if we plug this into the equation 2, we have minus 10x. Let me move it over a little. Minus 10x plus 4 times 0, and that is equal to 15. 4 times 0 is 0, so we're left with minus 10x is equal to 15. And we'll divide both sides now by negative 10. And if we do this, the negative 10 divided by negative 10 is positive 1. So x is equal to 15 over negative 10. And don't forget, this can be reduced if we divide top and bottom by 5. So we have negative 3 over 2. So the point that I have here is minus 3 over 2, comma 0. And don't forget, minus 3 over 2 is the same as negative 1 and 1/2, comma 0. Okay? Now, if we find a y-intercept, x has to be 0. So we have minus 10, and then in parentheses, x is 0. And that is plus 4 equals to 15 for y. So this here, minus 10 times 0 is 0. That leaves me with 4y is equal to 15. Okay? Now to get y by itself, I will divide both sides by 4. And when I do this, the 4 divided by 4 is 1, so y is equal to 15/4. Now 15/4 cannot be simplified, so my point is 0, comma 15/4, or we have 0, comma 4 3s are 12, 13, 14, 15, 3 3/4. So now if we plot these points, remember the first point, these 2 points will give me one line. And then these 2 points will give me my second line. So let's go ahead and get a graph here. Okay. Let's go ahead and get a graph. So we have 1, 2, 3. This is the x-axis. This is the y-axis. 4, -1, -2, -3, -4. 1, 2, 3, 4 here. Okay. We have -1, -2, -3 here. So the first point I want to plot is this point here. Okay. This point. We want to make sure that this point is plotted. So x is 1, so I'll do that in red, or let's, x is 1, y is 0. The second point I want to plot is this point here, x is 0, y is -2.5. So now you have to be careful because -2.5 will be somewhere in the middle. And if I connect those 2 dots, okay, if I connect those 2 dots, and I want to be precise as possible, seems like this is the equation 1, which we knew is 5x minus 2y equals 5. 5x minus 2y equals 5. Okay. Now, if we graph the second equation, which is these points here, x is -1.5, y is 0. So -1.5 would be somewhere over here, x, y is 0. And then my y value is about 3 3/4, okay? 3 3/4, which is somewhere all the way up here, just past 3.5, okay? And if I connect those 2 dots, okay, I have this equation. And clearly I missed one of my points, so we'll try again. So let's assume that's good. And the green equation is equation 2, which is 10x minus 10x plus 4y equals 15. Minus 10x plus 4y equals 15. Now if you look at this, okay, it will show you that the lines doesn't cross. But who knows what happens if I had extend these lines and continue going all the way up? Would they have crossed? Or if I had extended them downward, would they have crossed? Well, it appears that they're not crossing now, okay? So that means that possibly there is no solution, because remember, in my picture, right, that I had for my 3 scenarios, when they don't cross, when they're parallel, we have no solution, okay? So one way to tell if lines are parallel, okay, one way to tell if lines are parallel is look at the slope, rearrange this equation here, okay, and find the slope. And rearrange this equation here and find the slope. And remember, if the slopes are the same, okay, the lines are parallel. Parallel lines have the same slope. They don't share the same y-intercept clearly, so you know they're not the same line. So if I take those two equations, let's just check that. What is the slope of minus 10x plus 4y equals 15? And all this means is put it in the form y equal mx plus b. So I'm going to add 10x to both sides. If I do this, yeah, this becomes 0. So we have 4y is equal to 10x plus 15. And I divide every term by 4. So if I divide this by 4, this by 4, this by 4, 4 divided by 4 leaving it 1, so y is equal to 10x over 4 plus 15 over 4. So m here is 10 over 4 or 5 halves. Okay? If I divide this by 2 and I divide this by 2. Now, the slope of this line is 5 halves. The y-intercept, if you want it, is x is 0 and y is 15/4, which we saw before, right? Now, let's look at the slope. What is the slope? What is the slope of my second equation? Okay, so that was minus 10x plus 4y. What is the slope of 5x minus 2y equals 5? So solving for y, I am going to minus 5x on both sides. Okay, this positive and negative will cancel, leaving me with minus 2y is equal to minus 5x plus 5. And to get y by itself, I will now divide each term by negative 2. So we have the negative 2 divided by negative 2 becomes positive. So positive 1y is equal to a negative divided by a negative becomes positive. So we have 5x over 2. And a positive divided by a negative is a negative 5 over 2. So here we can see that the slope is also 5 halves. Okay, and the y-intercept, just for your knowledge, is 0 comma minus 5 halves. So clearly you will see that this slope and this slope are the same. And since they have the same slope, lines with the same slope are parallel. They are parallel. So if they're parallel, what you have just confirmed is that this problem has no solution. Okay? They are no solution. And I know this once again because if you remember when we first started, I gave you 3 scenarios. Okay? 3 scenarios when they're parallel. So we have looked at case 1 and case 2, and you could try problems on case 3 with graphing. This is the graphing method. Okay, So you can solve a system by graphing, but as you see, okay, as you see, you have to be very, very neat. So if there is a chance of making errors in the graphing, what do we do? Well, fortunately, there are two other methods that you can choose. Okay, there are two other methods. So note, we can use two other methods to solve the system. So we've looked at case one, which is graphing. Yes, we did. Second method we can use is called the addition method. And this is also known as the elimination method. Okay? And third, we have what is called substitution. Okay? The substitution method. Now, there are more methods, but these are the three methods that I will go over in this video. Okay? It is said that graphing is the most error-prone method. That all depends on one's neatness. It's also said that the addition method is the fastest and easiest method. Then that also depends on the individual. To me, addition and substitution seems to be more precise. Okay, so let's look at the addition method. Okay. Now, as we said, addition slash elimination. So that kind of gives it an idea of what we'll be doing. Now, in the addition method, okay, in the addition method, what we tend to do is to perform some algebra that will, when we add the two equations, either the x or the y's will cancel. Okay, one of them will cancel. For example, if we have, so now we want to solve the system by addition. X plus y is equal to 5, okay, and 3x minus y is equals to 3. Now clearly we can solve this by graphing, but we want to use the addition method. Our goal here is to always add these two equations. When you add them, when we add them, we will see that in this case, the y's will cancel. Okay? The y's will cancel. In some cases, or in most cases, this will not happen. And then you just have to perform a step before. So if we actually add these two equations, you will notice that 3x plus x becomes 4x. But plus y and minus y becomes 0. And we say they cancel out. Okay? So we say that these will cancel out. And that is equal to, if we add, okay, 5 plus 3, that gives us 8. And this is why it's called the addition method. Now, how do we get x by itself? Well, all we have to do is divide both sides by 4. And this will leave me 4 divided by 4 is 1x, so x is equal to 2. Okay? Now, if x is 2, Remember, I usually label my equations just so that we don't get carried away wrong. If x is 2, right, what I can do now is substitute x equal 2 into equation 1 or equation 2 to find y, to find the value of y. Now you have to decide which one you would pick. Pick any one, it doesn't matter. So I choose equation 1. And equation 1 is x plus y equals 5. X plus y equals 5. And x, we will let x be replaced by 2. So 2 plus y is equal to 5. That leaves me with 2 plus y equals 5. And then I will minus 2 on both sides. And if I do this, the plus 2 and a minus 2 will cancel. So y is equal to 3. Okay? Y is 3. Now we can check this, which we should. Okay? If we check, let's check. We got x is 2 and y is 3. And remember, we have two equations. Equation 1 is x plus y equals 5. Equation 2 is 3x minus y equals 3. And if we plug in those values, instead of x, I write 2, okay, plus, instead of y, I write 3, and see if we simplify the left side. So 2 plus 3 is equal to 5, 5 is equal to 5. So x equals 2 and y equals 3 satisfy equation 1. Now let's see if that satisfies equation 2, because if it does not, then it's not a solution. So we have 3, and instead of x here, we're going to write 2. And I will subtract, instead of y, I'm going to write 3. And we simplify the left side. So 3 times 2 is 6, minus 3, and 6 minus 3, 3 is equal to 3, so that check. So the solution is x equals 2 and y equals 3, or you can write it as 2 comma 3 as a point. Okay? Now, in this scenario, we saw that the x and y cancel when we add them. Okay? But sometimes they do not. They do not. Well, before we get into our next example, let me put some points that you should follow. So here are some strategies for solving a system of equation by the addition method. Okay, so these 6 steps is what we really say. So the first step is to decide which variable to eliminate. And note, in some cases, one variable may be easier to eliminate than the other. With some practice, you will notice which one it is. Step 2, we may have to multiply some equation, okay? We may have to multiply an equation to cancel either x or y. In the third step, we'll add the respective left and right side, which is what we did, and then we'll solve and so on. And then don't forget the last step we have to check. So let's see what happens when they don't cancel out, okay? Suppose I ask you to solve the system by the addition method. by the addition method. And our two equations are 4x plus 3y is equal to 10, and 2x plus y is equal to 4. Now you will notice that if you add these two equations, okay, nothing cancels. The x's or the y's does not cancel. Yeah. So decide which variable to eliminate. In my prior example, it was easy because if you notice, okay, the y's would have canceled because notice that they're the same value and the signs are different. And we know that when the signs are different and the coefficients are the same, they'll cancel. Minus 3x and plus 3x cancel. In this case here, they don't. So you have to decide. So it is your decision. You have to decide which variable to eliminate. Okay? Once you have decided that, then we will multiply either one or both equations. So notice that if this here was a minus 3y, the y's would cancel. Okay? Or if this here was a negative 4x, the x will cancel. So what we're going to do, we will choose, okay, we will choose to eliminate, right, to eliminate or cancel the x. To do this, it's a very easy process. So these are the two equations. What happens if I multiply this entire equation by minus 2? Okay, so the first equation, let's label these equations as we generally do. Let's call this equation 1, equation 2. The first equation will stay the same. So the first equation is 4x plus 3y equals 10. But the second equation, if you multiply every single term by negative 2, okay, this now becomes negative 4x negative 2y equals negative 8. So basically what I'm doing, I'm distributing that negative 2 to every single term in the parentheses. And I haven't changed the equation. All I did was multiply by a factor. Now, if you notice, we can add these two equations. And if you add them, your x's will get eliminated. Okay? So plus 4x minus 4x will cancel. And that will leave me, if I now combine these two terms, plus 3y minus 2y will leave me with y equals, and if I combine these two terms, okay, 10 minus 8, that is equal to 2. So here I have the value for y. Okay, my next step will be to substitute y equals 2 into equation 1 or equation 2, your decision. Okay, so you will have to pick one of the two equations. In this case, I'll choose equation 2, it doesn't matter. 2x plus y equals 4. So we will choose equation 2, which is 2x plus y equals 4. So now we're going to replace y with 2. So 2x plus, instead of y, I'm going to write 2. And that is equal to 4. So 2x plus 2 is equal to 4. And for x, I will now subtract 2 on both sides. And this will leave me with 2x plus 2 and minus 2 will cancel. And 4 minus 2 is 2. And now to get x by itself, I will divide both sides by 2, leaving me with x is equal to 1. So my solution is x equals 1 and y is equal to 2. Or we can write as a solution set 1, 2. Now don't forget, we should check this, right? You should always check. So check x equals 1 and y equals 2 into the equation. 4x plus 3y equals 10 and 2x plus y equals 4. So if x is 1, we have 4 times 1, okay, plus 3 times y is 2. And let's see if that, when we simplify it, will be 10. Now, we have 4 times 1 is 4. Positive 3 times 2 is positive 6. 6 plus 4, 10 is equal to 10. That checks. So in the first equation, check. Remember, you have to check both. So let's do it for the second equation. 2, x we said is 1, and y is going to be 2. And y is going to be 2. Okay? So simplifying this, we have 2 times 1 is 2, and then plus 2, and 2 plus 2 is 4 is equal to 4, so this check. So it is confirmed, or it is checked. Okay? It is checked. So the only difference is that in this case, sometimes you will have to multiply an equation by some number as we did here. And sometimes you will have to multiply both equations, okay, not just one, okay? You will have to multiply both equations. So let's look at another example. Solve the system example by the addition method. Okay. And in this example, I'm going to have 6x plus 3y is equal to 11. Let's say not 11. 6x plus 3y is equal to minus 1. And 9x plus 5y is equal to 1. So observe here that if you try to add them, none of the x or the y's will cancel. So let's call them, give them name, equation 1, equation 2, okay? So I have decided, okay, let us eliminate the y's. So what I'm going to do in this scenario, 6x plus 3y is equal to negative 1. and 9x plus 5y is equal to 1. Now, notice a couple of things. They're both positive. So one of them will have to be multiplied by a negative number. Okay? And here is what a little hint. When you're multiplying both of them, okay? When you're multiplying both of them, look at what I'm going to do. I'm going to take the 5 from here. Oops, let's use highlighter. I'm going to take the 5 from here and multiply the top equation by 5. And I'm going to take the 3 from here and I'm going to multiply the second equation by 3. But as I said, one of them has to be negative. So make either the 5 or the 3 a negative. Okay? Make either the 5 or the 3 a negative. I'll choose this to be negative. Doesn't matter. Now, if you distribute that negative 5 to every term in the first equation, you will now have the equation minus 30x minus 5 times 3 is 15y is equal to positive 5, right? A negative times a negative. And if you distribute now 3 to every term in the second equation, you will end up with 3 times 9 is 27x, 3 times 5 is positive 15y, and 3 times 1 is 3. And now, if you add these two equations, okay, if you add them, you always add minus 30x plus 27x gives you negative 3x. The minus 15 and the plus 15 will become 0, and 5 plus 3 is 8. Okay? To get x by itself, we will divide both sides by negative 3. So negative 3 divided by negative 3 becomes positive 1. So x is equal to minus 8/3. And it's okay. We can have a fraction. Okay? Now, remember, we're not finished because we need to solve for x and y. So now we'll substitute x equals minus 8/3, okay, 8/3 into equation 1 or equation 2. So you will have to pick equation 1 or equation 2. So let us choose equation 1. And equation 1 we knew is 6x, okay, plus 3y equals negative 1. Let's just make sure we copy that correctly. 6x plus 3y equals negative 1. Okay? And what we'll do is wherever we see x, we will replace. So x will be replaced with minus 8/3. And that is equal to plus 3y equals negative 1. Now you will see that this can be simplified. Okay? The 6 and the 3 becomes a 2. So when you distribute here, this becomes minus 16 plus 3y is equal to negative 1. And I'm going to add 16 on both sides. Okay. The minus 16 and the plus 16 cancel, so we have 3y is equal to 15. And to get y by itself, we will divide both sides by 3. By doing this, we see that y is equal to 5. So we have the solution. X happens to be a fraction, minus 8/3, and y is equal to 5. Okay? And don't forget, we have to check. We should check. Let's check. So our two equations that we had, or we have two equations. Two equations are 6x plus 3y equals -1 and 9x plus 5y equals 1. So 6x plus 3y equals -1, and we also want to check 9x plus 5y equals 1. So let's do it. I mean, we have fraction. It's a little bit technical, but we can do this. -8/3. We have built up our confidence where we can now do this. Plus 3y is equal to -1. Now you will notice here, okay, that the 6 and the 3 becomes a 2. 6 divided by 3. 2 times -8 is -16 plus 3y is equal to -1. So rewriting that, oh, I need to plug in my y too. Oops. We need to replace the y because we're checking both x and y. And instead of y, I'm going to write 5. Replace the y. Okay. So 3 times 5 is 15. Okay. So what do we have? We have 2 times -8, which is -16 plus 15. And -16 plus 15 is -1 is equal to -1. That checks. Don't forget, we have to check the second equation also. So we have 9. Instead of x, we're going to write -8/3 plus 5. Instead of y, I'm going to write 5. And we want to see if when we simplify that, we get 1. Now, we've seen that 9 divided by 3 is 3. So 3 times -8 becomes -24. So -24, 5 times 5 becomes plus 25. And -24 plus 25, 1 equals 1. That check. So it is confirmed that x equals, x equals -8/3 and y equals 5 is the solution. Okay? So we have confirmed that. Now let's look at one more example, because I said to you that there are some cases where there'll be no solution. Okay? Example, let's solve by addition, by the addition method. And let's say we have 5x minus 2y equals 5, and we have minus 10x plus 4y equals 15. So we always give them labels. Okay? Now, you notice if you add them, nothing cancels. So you have to decide, what do you want to cancel? Do you want to cancel the x, or do you want to cancel the y? Do you want to eliminate the x, or do you want to eliminate the y? Well, they're both sign different, so it doesn't really matter here. All you have to do is multiply by some factor. So you'll notice that if this was a 10, this would have canceled. Okay? Or if this was a 4, the y would have canceled. So you just have to decide on which one. So let's eliminate the y's. So 5x minus 2y is equal to 5, and minus 10x plus 4y is equal to 15. So I said, let's eliminate the y. Okay, that's what I've choose. And to do this, we'll multiply this one here by 2. Okay, if you multiply that entire equation by 2, if you distribute the 2, you will have, okay, you will have 10x minus 4y is equal to 10. Okay, and in the second equation, that equation stays, so you have minus 10x plus 4y is equal to 15. Now, if you add them, you will see that the minus 10x and the plus 10x is 0. That's 0. The minus 4 and the plus 4 is also 0. So on this side, you have 0 is equal to, and 10 plus 15 is 25. And there is no way 0 is equal to 25. So this problem has no solution. Okay? No solution. Now, what happened if you had 0 equals 0? If you had 0 equals 0, or if you have 25 equals 25, then you will have the case of infinite solution. So I will leave that one for you to obtain on your own or to practice on your own. Okay? So no solution, if you recall, means that if you had graphed these lines, you would see that they are parallel lines. Okay? Now, let's look at the last method here, which is substitution method. Substitution method. Now, in the substitution method, there's a lot of algebra. Okay, so you're gonna have three methods to work with. Okay, and like I said, there are more methods. Okay, in a higher level class, there's the matrix method and so forth. So if we have solve, okay, solve, we have 2x minus 3y is equal to minus 6, and then we have y is equal to 3x minus 5. Okay? So notice that the second equation, okay, equation 1 is written in the form ax plus by equals c, but equation 2 is written in the form y equal mx plus b. Okay? So that kind of gives us a hint to which method, right? If I have an equation where it's written in the form y equals or x equals, then I use the substitution method. Now, remember, you're given that y is equal, okay, to 3x minus 5, okay? So what we do is we take equation 1 and replace / substitute 3x minus 5 where we see y. Okay, so we have 2x minus 3, but instead of y, okay, I'm gonna write 3x minus 5, and that is equal to negative 6. Okay, that was equation 1, right? We got this from equation 1. Remember, equation 1 we know is 2x minus 3y equals negative 6. Okay, so if we simplify this now, this becomes 2x minus 3 times 3 becomes minus 9x, minus 3 times minus 5 becomes plus 15, and that is equal to negative 6. Combining like terms, 2x minus 9x becomes minus 7x plus 15 is equal to negative 6. Okay? We will now subtract 15 on both sides because our goal is to solve for x. If we subtract 15 on both sides, we have minus 7x plus 15, and minus 15 is 0, and this is now equal to minus 21. And finally, to get x by itself, We'll divide both sides by -7. Okay. You will notice that the -7 divided by -7 becomes +1. So x is equal to, and a negative divided by negative becomes positive. 21 divided by 7 is 3. So x is equal to 3. Now we will substitute, okay, x equals 3 into equation 1 or equation 2 to find y. So you have to decide, do you want to pick equation 1 or equation 2? Clearly, equation 2 seems to be easier. Y equal 3x minus 5. So y equal 3x minus 5. And x is 3. So y is equal to 3 instead of x. I will write 3. So y is equal to 3 times 3 is 9 minus 5. Y is equal to 4. So we see the solution is x equals 3 and y equals 4. Now don't forget, I'm going to leave this up to you as a check. Check your answer. Okay? You have to check your answer. So make sure you take these two equations and you go and plug it back. So here is some strategies just as we did before. Here are some strategies. Okay? Solve either one of the equation for x or y. In my last example that was done, this step is not necessary, right? So we've seen this. In my last example, this step was not necessary, okay? So we'll take this out. Okay? And then we substitute the expression and so forth. So these are some guidance or some strategies to solve. So let's look at one more example. Okay. So example, solve by the substitution. Now, when I don't tell you which method, you can choose any method you want. I need two equations, so here's an example. 2x plus 3y is equal to 5, and we have x minus 2y is equal to 6. So here is equation 1, and here is equation 2. So remember, one of the equations have to be in the form x equals or y equals. So you have to pick equation 1 or equation 2. So if you notice, here is a hint. Hint. Okay. Look at both equations and see if x or y, okay, has a coefficient of 1. So that means, look, here there's a 1 there. And choose this equation. Okay? So we're going to take x minus 2y is equal to 6. Okay? And to get x by itself, we're going to add 2y to both sides. If we do this, we have x is equal to minus 2y plus 2y cancel, and that leaves us with 6 plus 2y. So here is what we're going to replace x with. Okay? Now, So here is our x value. So notice we choose equation 2, right? This was our equation 2. Now we're going to take equation 1, which is 2x plus 3y equals 5. And we will replace x with what we have up here. So this now becomes 2 in parentheses 6 plus 2y. And then we write our plus 3y equals 5. Yeah. And the whole point of doing this is so that you can have an equation with only one variable. If we distribute now, 2 times 6 becomes 12, 2 times 2y becomes plus 4y, plus 3y is equal to 5. Combine like terms, okay, we have 12 plus 7y is equal to 5. And to get y by itself, we'll minus 12 on both sides. And if we do this, the plus 12 and the minus 12 becomes 0. Okay, so I have 7y is equal to minus 7. And to get y by itself, we will divide both sides by 7. So we have y is equal to minus 1. Okay, y is equal to minus 1. And now to get x, to find x, we substitute, okay, y equals negative 1 into equation 1 or equation 2. Okay, so you have to pick either equation 1 or equation 2. Doesn't matter. Let's pick equation 1, 2x plus 3y equals 5. So equation 1, 2x plus 3y equals 5. Okay, let's just confirm that. 2x plus 3y equals 5, yes. And we're going to choose y equals negative 1. So 2x plus 3, instead of y, I'm going to write negative 1. And that is equal to 5. So 2x, 3 times 1 is negative 3 equals 5. And then I will add 3 on both sides. So we end up with 2x minus 3 and plus 3 cancel, and that is equal to 8. And 2x is equal to 8. We'll divide both sides by 2. Notice that the 2's will cancel, so x is equal to 4. So we see our solution is x equals 4 and y equals to negative 1. Don't forget, you should check. Okay? So I'm going to leave the checking for you as a task. Okay? So there are always more examples, and some examples will be different from each other. So I will leave you to try examples on your own. Okay? So you should try a few examples. Okay? If you want, I would ask you to try these examples. Okay? And I'm not going to specify which method, I will just say solve. So you could try whichever method you want. So solve the following. Okay. Problem 1, 4x minus, Or let's start out with a simple example. X minus y equals 4, and minus x plus 2y is equal to negative 3. Okay. Number 2, how about if we have 4x minus 7y is equal to 3, and 5x plus 2y is equal to negative 3. Okay. And one more, 3. If we have 3x minus 4y equals 7, and 6x minus 3y is equal to 5. So I am asking you to try these 3 examples as practice, and you can also use all 3 methods for every problem and see what happens. Okay.